So today we need to do a warm-up, right? We need to do a warm-up based on our equation for compound interest. Remember, we were looking at a thing called the present value. And that equation was literally an equation that undid the future value. And remember, the future value was this. A is equal to P1 plus I, all raised to the n. So what we did was we used the original compounding interest formula and said, hey, what would happen? What principal would we need to get the final amount? And what we have to do is we have to basically go backwards in time. And I want you to imagine that this negative n actually goes backwards in time. Now, remember, that is called the present value, and that finds the principal based on the amount that we want at the end. So imagine if I gave you this problem. Karen would like to have $9,600 at the end of 3 years. Okay? Now, she invests, She invests the money at 7% quarterly. Okay? So if she invests at 7% compounded quarterly, so this compounded quarterly thing means something, right? We need to use the formula to figure out how much she should deposit now in order to find out what she actually needs at the beginning. So we need to start with this basic equation, but we need to start with all the letters that we use. And anytime we're doing some sort of compound interest, I always start by writing A, P, I, and N for every one of the variables in this basic equation. Now, we know that the final amount is going to be 9,600. So I'm going to put 9,600 here for A. All right, and this is going to happen in 3 years. So the first thing I'm going to do is I'm going to put N is 3. Okay, and then I also notice that it's 7%. Now 7% can be written as 0.07, right? Now the only issue is that we have to account for the concept of 7% compounded quarterly. So in order to do that, we have to use the idea that basically when we have our rate, we're going to divide by 4, but then for our years, we must times by 4, which means our rate is going to equal 0.0175. And the number of compounding periods, n, is going to be 12. So now we can use our present value equation, which is going to be P is equal to A 1 plus I raised to the negative n. And when we punch that in, you're going to get the following. P is equal to 9,600 bracket 1 plus 0.175 raised to the negative 12, which we can simplify on paper to be 9,600 times 1.0175 raised to the negative 12. And then we can punch that into our calculator using this method here. We're going to write on the calculator, we're going to write the following. 9,600. We're going to times it by 1.0175. And then we're going to use the x to the y feature on our calculator, and we're going to raise it to, in brackets, negative 12. And your final answer is going to be $7,795.76. You just have to watch the rounding. So all we have left to do is to just ensure that we have answered the question for this problem. So far, we haven't quite done it yet. So let's go and write our final answer for this problem, the concluding sentence. So in this case, when we're solving our problem, we're actually determining that we need to have $7,795.76 now in order to have $9,600 in 3 years. Now, that is a powerful thing to have because you can start planning your future when you know how much you have to invest now to have enough for, say, that car that you need in 3 years. Okay? So you let your money work for you. All right? That is the power of present value. So now let's move on to the next lesson. So today what we'll be doing is we'll be using compound interest to find savings in, say, repaying something early, like a credit card or a car payment, or pay off your car early because you know if you pay it off early, it's going to cost you just a little bit less money. Okay? Now, let's go over some new definitions that we haven't discussed so far. Okay? So one of the key things in loaning money or paying money back is the person that you're buying money from or paying money back to. Okay? That person is called the creditor. And this is the definition of a creditor. Now, these people are a person or organization that lends money out to other people, right? So they make an arrangement with you that says you're going to pay a total amount of money at the end of a certain amount of time, maybe N years, maybe 6 months, whatever, right? So maybe you say that by the end of 3 years, you're going to pay me back $9,600, right? Now, in lending, people get discounts sometimes. They sometimes get discounts by basically paying off their loan just a little early, right? Now, the lender doesn't want to be out money, but they want the value of their money that they are owed now. So imagine if you had $9,600, but you went and paid off. You had $9,600 to pay off in, say, 3 years. Sorry, in, say, 7 years. But you decided to cut that down by 3 years. There's a certain amount of money that would be less than $9,600, which would represent the total amount of money that you owe today for that loan. And that is what we call a discount. Just think of it as an investment that is sold at a value less than its actual price. Okay? Think of it as paying your car loan off, right? You need to pay the present value of the loan, which is less than the actual payout at the end, right? So here is what we're going to use. You see these words, creditors and discounts and present value. We're going to use that to help us complete this sentence. So creditors often sell their loans to other creditors, right? They discount the value of the loan by calculating the current present value at current rates. So in essence, you can reduce your costs by buying out a loan years in advance. So now let's move on to the first problem of the day. So remember, I told you that we were working on problems that you could basically use present value to figure out how much you would owe for something if you paid it off early. Okay? So here is a simple problem. Leslie has a loan of approximately 13%. Okay? Interest rate, and it's compounded weekly. So you know that something that is compounded weekly means we have to use the compounding number of 52 weeks per year. Now that we've done that, this is how much you got to understand she owes. She owes $4,300. Okay? That's due in 2 years' time. Okay? That is our problem. So we always start by understanding if we have the thing compounding, that means we're using compound interest. And so because of that, we have to use the APIN moniker that we use to help us figure out what we're going to be doing for our problem. Okay? So in this case, it says she owes $4,300 in 2 years' time. And that is our A value. Okay? Now, the question asks us, what is the discounted value of the loan? So let's go and figure that out, shall we? So you don't know what the original amount is if we pay it out a little early. So here's what I need you to do. You got to remember that 13% can be written as 0.13. Now, you can get that by doing 13 divided by 100 at any time. So I would just go 13 divided by 100 so I don't have to think too hard. And then I know that that gives me 13%. Okay, I would just do that on my calculator and get my numbers written out. So I get 0.13 as my decimal. Now, the N. So the N tells us that in 2 years' time, this thing is due, right? Now, here is what you need to know. We need to use that 52 weeks per year to help us change our I value into something that is compounding over 52 weeks. So we have to divide it by 52. So we take 0.13 divided by 52, and you end up with this number for I, 0.0025. When you simplify that in your calculator. Now, here's the cool part. So remember, when I divide I by 52, I have to take my number of years and multiply by 52. My time and multiply by 52. All right, so now that I've got that, I've got 104 as my N value, which means that now I can calculate P from our equation. So we end up with the following. I'm going to write it in black. P is equal to A, 1 plus I to the negative N, because we know we're looking for the present value. And now we just substitute. So P is equal to, well, 4,300. And then we have 1 plus 0.0025 raised to the negative 104. So now we can rewrite that as P is equal to 4,300 times 1.0025 raised to the negative 104. Now remember, on our calculator, here's how we do this. We're going to write 4,300. We're going to times it by 1.0025 raised to the, well, we use x to the y or x to the box raised to the negative 104. And you're going to get the following answer. The following answer to a couple of decimal places. 3316.5976. Uh-oh, not sevens. 0.597746. Now, we need to change this into something we understand because this is money, isn't it? So that means this money is going to be 3316. And all we have to do is we have to look at this number here in order to simplify the 59. The 59 becomes 60. Okay? And we answer the following question at the end. Remember, it asks us, what is the discounted value of the loan? So let's answer that in our response at the end. So now this is my final answer. So if you're ever doing something really quick on a test, just put a box around it. And then what I want you to do is I want you to put this final statement. The discounted value of the loan is $3,316.60, and that's if we pay it 2 years early. So that is the discounted loan. All right, and now we'll move on to finding a discount in savings if we pay off something early. Let's take a look. So this problem says, suppose you find a TV that you want to buy. The store, maybe Best Buy or whatever, has payment plans, right? The present value of each, it says, find the present value of each plan to determine which is the better offer, right? You can invest 4.2% compounded quarterly. Now, you know, I'm going to write this in red because this compounded quarterly we can use later. Now, there are two offers. Option A, you go to the front desk and you pay for your TV right now. Okay? You're paying for your 70-inch TV right now, and that's going to be $2,399.99. Option A, done. So it's literally done because we pay that $2,399.99 right now. So we're going to sit down now and we're going to see what would happen if we paid this $399 now and $2,300 1 year after, using our 4.2% compounding quarterly. Okay, so let's see how we're going to solve this. So for option B, step 1, we're literally going to have to find out how much we have to put in an account. So we have $2,300 at the end of 1 year with using this concept of having 4.2% compounded quarterly. So in order to do this calculation, we have to start with our APIN since we're using compound interest again. Now, here are the numbers that we know. We know that we want 2,300 at the end, so that is our A. We don't know what our P value is, but we do know what our I value is. Our I value is 0.42. Okay, and then remember, it's compounded quarterly. So what we have to do, if we have quarterly, we have to divide 0.42 divided by 4. And that gives us an exact number of 0.0105. Okay, now for N, we need to figure out what N is. Now, N is actually, well, you guessed it, because it's supposed to be picked up in 1 year. N is 1 for the number of years, but then we have to times it by 4. So remember, if we divide our rate by a number, we must times our number by that number as well. So now we end up with 4. So now here's our basic calculation. So we have P is equal to A, 1 plus I to the n. So we are looking for when our final amount, what our initial amount is to get this thing. So let's go and substitute accordingly. So we get P is equal to, well, 2300 times 1 plus 0.0105 raised to the negative 4. So that simplifies to P is equal to 2300, and this makes our calculations easier on our calculator. 1.0105 raised to the negative 4. Punch that in your calculator, and you're going to get approximately this. P is equal to $22.05.88. Now, in this case, for step 2, basically, this is what we have to do in order to determine if this is worth it or not. So for step 2, we have to find the total that we spent today. So remember, this number, this amount of money here, represents the amount of money we'd have to put in the bank today. And then we also have to add that $399 to find out the total amount of money that we put in. Okay, so now that total is going to be this. So that total is $2,604.88. Now, when we compare option A to option B, we're going to say, therefore, option A is better because it's cheaper. Now, in order to justify why something is cheaper, just make sure that you subtract the two to show me how much you actually saved. And that's what I did here. So in this case, you're going to save $204 if you pay now rather than later. And that is basically the mechanism that is used when you're asked to pay now or pay later. If you pay now, you're definitely going to make a little less. You're going to pay a little less. But when you're paying later, that company is always trying to claw extra money from you. So most likely it's going to cost you more to pay for something in the future like this, even if there is a $399 down payment. Okay. All right. So now the questions that I have for you are posted online. Go and work on them, please.